Hey guys, in this video tutorial, we are going to discuss about the C++ standard template library or the STL. Now, we know that in C++, while creating certain data structures, we have to write a very long code. It's so much tedious sometimes, but C++ standard template library provides C++ class templates, which help users to implement those data structures and their functions. So in this video, we are going to see the three most popular data structures, which are vectors, queue, and stack, which are frequently used in competitive coding. So the first data structure we are going to see is vectors. Vectors are the dynamic resizable arrays in which the elements are stored in contiguous memory location. As these arrays are dynamic, the memory allocation is only done when the new element is inserted in those arrays. The element's insertion and deletion is done at the end, and there are certain functions for that. We will discuss them. To use the vector keyword, we should add bits header file in our code. There are three methods which are used to create the vectors frequently. One is you can create an empty vector. The second is you can create a vector with some arbitrary size n. Okay, so we can take n and we can assign any value. Okay, the third method is to initialize all those values with some integer. Here we are considering the integer type vector. Now we will see how to add elements in the vector. The function pushback is used to add the element in the vector. So we are going to add 1 and we will replicate this line, and we will say add 2, 3 and 4 to vector. Okay, so our elements will get added when we will run the code. We will run a for loop to see whether the elements got added or not. Okay, let's run our code. Yeah, the elements are added in the vector. Now we will see the function which is used to get the size of vector, which means how many elements are added inside the vector. It is written as v1.size. Our code has written the answer 4. Now let's shuffle the elements inside the vector and write the function to sort those elements. So first we will shuffle the elements and we are going to write a function which will sort our vector. Sorting in vectors. We will write sort and we'll write v1.begin and comma v1.end. So we are moving our pointer from beginning to end. And after sorting the elements, we will again run a for loop. The elements in the vector got printed in sorted order. The next data structure we are going to see is the queues. Queues are also the dynamic resizable container adapters and follow FIFO rule, which is first in first out, which means the element which comes first needs to be deleted first, and so the element insertion in queues is from the last. Moving on to the queues implementation, we write queue and data type int and we give it a name which is queue here. We use the push function to push the elements in the queue. Similarly, we will replicate it for some elements. We use queue.front function to get the first element of the queue. and we use q.back function to get the last element of q. So we have got our elements printed. The first element of q here is 1 and the last element is 4. Now let's run the pop function single time and let's check for the front of q. This time the front of our q must be 2. So let's comment out the above code and check for the q.front. Okay, we have got the front of q as 2. We have q.size function to check the size of q. Here in this case we have popped one element, so the size of q should be 3. Nice, our code has written the answer 3, which is the size of q. We use q.empty function to check whether our q is empty or not. It is a boolean value, either 0 or 1. So this time our q is not empty, so our q.empty function should return 0. Our function has written 0. Now let's give it a try and run the pop function multiple times. Nice, our q.empty function has given the result 1. The next data structure we are going to discuss is stacks. They are also dynamic resizable container adapters and they follow LIFO or FILO rule. That is last in first out or first in last out rule. That means the element which is inserted first needs to be removed at last. The element insertion and deletion in stacks is done from the top itself. In other words, stack is considered as a vertical array. The declaration of stack is also same. We write stack, angle bracket, and then data type, and we give it a name. Okay, now we are going to do the same. We are going to use the push function to push the element inside the stack. We use .top function to get the element which is at the top. Okay, we will run our code. We have got the answer 4. That is the element which is at the top. Okay, now we will run .pop function which will pop the element which is at the top. Let's see what our top becomes now. Now this time our top is 3. We use the same .size function to print the size of stack. We have popped one element, that's why the size of stack is 3 here. And we use same stack.empty function to check whether the stack is empty or not. Okay, our stack has 3 elements, which means it is not empty. Now if you run the pop function same 4 times, which is equal to the number of elements you have inserted, then we are gonna get 1 as the answer.